Okay, so we are now on lesson 9. We're going to be talking about the composition of functions. We spent a lot of time talking about functions. We talked about the domains as inputs, right? And the range would be outputs, okay? At least that's how we reference them. Domain represents independent variables typically, and range represents the dependent variables, right? Okay, so we talked about that as like a broad definition of functions. And then we kind of talked about functions as if they are becoming this new number, right? It's this new sense of a value. Okay, it could take on multiple values, but we treat it very much like we treat numbers, like we call them even and odd, right? Or maybe they're neither. You can do different algebra or just arithmetic, right? You can do stuff like add two functions together. Right? You can add them, subtract them, multiply them, divide them. Okay, you can do this. And so one other thing that we can do with functions is that if we're given a function, right, f of x equals some formula like 2x plus 9, and you are given a number, right, like 3, you can always plug that 3 into the function, and you can find the function value, right? You can plug numbers into functions. Well, if functions are this new form of a number, then it's possible that we can plug a function into another function, right? That's where we get composite functions, okay? We're composing functions. All right, and so I don't know why we have a little blank right here, but we'll just ignore that. When one function serves as the input of another function, the result is called a composite function. Okay, and so here's some notation to keep in mind. Okay, here is the notation that says if you're going to plug a function into another function, so in this case, g of x is being plugged into the function f, then you could notate that as g of f of x. Now, people will oftentimes confuse this notation to mean this, which is multiplication, right? Where you're multiplying the two functions together, which is definitely not what we're trying to do here. Okay, so I do want to point that out. Don't make this mistake. That is multiplication. This is composition. So I like to think about that as an O, like the word of. So f of g of x. Okay, so when you compose one function with another function, you produce a new function. Okay, and that new function, okay, you can think about it in words here, the outputs of the inside function, and so in this case, g of x, if you were to plug a number in for g of x, right, that would give you an output. Well, the output of g of x gets plugged into f of x. It becomes the inputs of the exterior function. So the interior function's outputs become the inputs of the exterior function. Okay, and so you could think about that as, well, we'll do an example later. All right, so here's some just, I guess, verbal representations of a composite function. So you can imagine there's a flight that goes from New Orleans to Atlanta. Right? You can think about that as one function that carries you from one city to another city, and then from Atlanta to Chicago. Right? So it's basically as if you had two functions, right? Your first function and your second function. Okay, or let me go stay consistent with the notation. We'll do g of x first and then f of x. Okay, and so if you think about it like that, okay, great. There's a flight that goes from New Orleans to Atlanta, then from Atlanta to Chicago. That is as if you took the output of this one, which would be Atlanta, and you use it as the input for f to get you to Chicago, right? But if you think about a new function that's produced, you could think about it as one combined function, a composite function that takes you from New Orleans to Chicago. Okay, it's kind of like having a direct flight or just considering the two together. Let's get to some examples here. So here are two functions, f of x which equals 2 times the square root of 9x plus 1 minus 4x plus 1. And g of x is 2x plus 1. Okay, and notice the way that this is labeled here. We have g of f. Okay, and so f is on the inside. If you can think about that, that just means that this is g with f of 2 plugged in. Okay, g of f of 2 plugged in. So what we can do here is figure out f of 2, right? Find the output of that. That output will become the input for g. So f of 2 would be 2 the square root of 9 times 2 plus 1 minus 4 times 2 plus 1. Okay, 9 times 2 is going to be 18 plus 1 is 19. Minus 8 plus 1. So 2 the square root of 19 minus 7. Okay, that would be the output of f. Seems more complicated than what I wanted it to be, but oh well, we'll go with it. Okay, and so that's the output of f, so that will become the input of g. So g is 2x plus 1. So what goes in that blank? 2 the square root of 19 minus 7. That's now my input. And so I will simplify that. Distribute this 2 here. That would be 4 the square root of 19 minus 14 plus 1. And then negative 14 plus 1, of course, is 13. So, or negative 13. Okay, so there we go. That would be the composition. Now, to go from one function, find the output, and then use that as the input of the next function, that's one way to do it. Another way to think about it is let's just find a single formula for the function. Okay, so I need to go back and see exactly what f of x was. That was, let's see. That was 2 the square root of 9x plus 1 minus 4x plus 1. Okay, I think I jotted that down right. Okay, and then g of x is 2x plus 1. All right, so I have these two functions. I want to find the new function, the direct flight, right? That's what I want to find here. And so I can compose these two functions, g of f of x, by doing what we just did a second ago. I'm going to start off with g, g, and inside wherever x is located, I'm going to plug in f of x. But what is f of x? That would be 2 the square root of 9x plus 1 minus 4x plus 1. So for g, which is 2 times x plus 1, will become 2 times 2 the square root of 9x plus 1 minus 4x plus 1. We distribute that 2. Minus 8x plus 2. Of course, plus 1. And that'll add together to be a plus 3. So g of f of x equals 4 the square root of 9x plus 1 minus 8x plus 3. Okay, and so this is a function that I could use. It's a formula that I could use to find this here without having to do the 2 steps. Okay, matter of fact, let's try that out. Okay, let's see if we get the same thing. Hopefully we do. 9 times 2, 18 plus 1, 19. 8 times 2 is 16 plus 3. Negative 16 plus 3 is going to be a negative 13. Yep, negative 4 square root of 19 minus 13. Negative 4 square root of 19 minus 13. Okay, so that's two different ways you can get to the same thing. One is two separate functions that are composed. The other one is composed of two functions to get the new function, the new formula, and go from there. Okay, so the composite function, that's kind of the point I was just trying to make. The composite function is a new function, and that new function has its own domain and range and all those properties, right? And so that's what we're going to focus on from here on, okay? So if there's a new function, you have to think about its domain and its range. We'll just kind of consider the function that we already had here. And here's the graph. And here's a question. So it says find the domain of the new function g of f of x, which is for the square root of 9x plus 1 minus 8x plus 3. And from here, you can look at the graph. And let me kind of explain it really quick. The red one is f of x. Okay. The blue one is g of x. And the black one is g of f of x. Okay, so you kind of have a little key here. So the red one, you see how it has this kind of shape here. Notice the domain. The domain seems to start right at the left of 0. Okay, can't really tell exactly what it is, but just to the left of 0. And it seems to run forever to the right. So something like 0 to infinity would be the domain of the red one. The blue one has a domain of negative infinity to positive infinity. It goes forever to the left and forever to the right. Okay, well, the domain of the new function will consider the input function, right, f of x. It's going to take the domain from the input, and then from there, it'll match it up against the new formula. So really, g of x doesn't play any role here. Okay, just the interior function, which would be f. All right, so let's find the domain of f really quick. Put it in red again. Remember, f of x is 2 the square root of 9x plus 1 minus 4x plus 1. I think I keep forgetting. Go back up. Make sure 2 square root of 9x plus 1 minus 4x plus 1. Yes, okay. All right, so I'm going to take this one and find its domain. So remember, when you're dealing with domain, you're talking about the x values. We're talking about an implied domain, the x values that you can plug into this function without violating one of the math rules, right? So you don't want to end up dividing by 0. You don't want to end up having a negative in the square root, under the square root, or a fourth root, any even root. You don't want a negative. That'll lead to complex numbers, and we're not trying to deal with that right now. We're trying to deal with real numbers. Okay, so I want to avoid any situation where I divide by 0, right? Or have a negative under a square root, or again, any even root. Okay, I don't want either of those. Well, I'm not worried about dividing by 0 because I don't have any fractions here, right? I don't have x in the bottom of anything. So dividing by 0 is not really an option. But I do have a square root, so I need to be careful of the square root of a negative number. So the interior of the square root, that 9x plus 1, that cannot be negative. So in other words, it has to be bigger than 0, or it could equal 0, right? 0 is not negative, so it could equal 0. 9x plus 1 is greater than or equal to 0. Again, I'm only focusing in on this piece right here because that's the only place where I could potentially get a negative under a square root. So 9x plus 1, I want that to be greater than or equal to 0. If I solve this inequality, I have 9x is greater than or equal to negative 1. 0 minus 1 is negative 1. And then divide both sides by 9. So negative 1/9. Okay, negative 1/9 is close to 0. So if you think about it like that, that's why you can see this graph is a little bit to the left of 0 here. That's negative 1/9. Okay, so the domain of f of x is negative 1/9 inclusive to infinity. Negative 1/9 to infinity. Okay, now let's compare that to the new function. Okay, this is the function, this is the domain of the input, right? Now let me look at the domain of the original function. Okay, so I'm starting off with this as my domain. Is there, or are there any other considerations, right? I'm already watching out for this square root of x, or square root of 9x plus 1. But in the new function, right, which is different than the old function, in the new function, are there anything else, any other things to watch out for, right? Do I have any new square roots? No, they're the same. Do I have any fractions where x is in the bottom, in the denominator, where I could end up dividing by 0? No, right? No. And so this domain is going to hold up. That's going to be my overall domain of my new function, negative 1/9 to infinity, bracket, right? Because it's a closed circle. Negative 1/9 is included, to infinity. Okay, so just to reiterate the process. Find the domain of the inside function, the one in the middle. Then look at the formula for the new one and compare it. See if there's anything additional to watch out for. It's possible that you ended up with a new square root and you would have to maybe cut out another value. So you'd have another open circle here or something, right? Maybe like a 2, right? Then you would have to, write out a different interval. Okay, that's possible. Not in this problem. Here's the last example here. Let f of x equal 1 over x and g of x equals the square root of x plus 5. Find g of f of x and its domain. Okay, again, I'll reverse the order. G of f of x. So I need to start off with g of x, which is the square root of x plus 5. But instead of x plus 5, of course, I'll put 1 over x in x's place. Okay, so I composed them. All right, so that's the first part of this question, to find this. All right, and so now to find the domain. Okay, consider the interior function, which is this f of x first. Okay, do that in red, f of x is in red. So I will consider f of x first. And you can look at that one, right? 1 over x, you can't have x in your, or 0 in the domain, right? You cannot allow x to be 0, because if you do, you have 1 over 0, right? So that one's actually easy to spot. You don't have to really solve that one. But x can be anything bigger than 0 or smaller than 0, right, for f. All right. Now, let's look at the new function here. The new function, the square root of 1 over x plus 5. Okay. First of all, I can't have x be 0, right? Because inside here we see we get 1 over 0. That's okay. We've already taken care of that. There's no issue with that. But we cannot have a negative in that square root. So what we need to do then is take that square root and say that it has to be bigger than 0 or equal to 0, right? 1 over x plus 5 has to be greater than or equal to 0. If that's not the case, you have a negative, right? A negative expression, and then you would have a negative under that radical. Okay, so let's solve that. Subtract 5 from both sides. Let's multiply both sides by x. So we get 1 is greater than or equal to negative 5x. Okay, and there's a couple of ways you can think about this one here. I'll just divide both sides by negative 5. So negative 1 over 5 is less than or equal to x. Y'all remember that rule, right? I'll make a little footnote here. When dividing or multiplying by a negative, flip inequality sign. You might want to remember that if you don't already remember that. Okay, and so it's a little bit easier to flip it around. Again, if you're reading this like a sentence, you don't want to put, again, it's out of order, right? You want to put the subject of the sentence, right? X first. So X is greater than or equal to negative 1/5. Think about it, it means the same thing, right? Negative 1/5 is less than X. X is bigger than negative 1/5. Okay, another way to look at it is see how this inequality is opened up towards the X. It's still opened up towards the X, all right? So it means the same thing. All right, so that is something else, right? This new domain, our new functions domain, starts at negative 1/5. It includes negative 1/5, and it goes forever to the right. Okay, but remember, we have to match that up against this one's domain. And this one says, all right, we're not so worried about this piece right here, because this doesn't have it. Because it has to be greater than negative 1/5 or equal to it. But it cannot be 0, right? Because still plugging in 0 will cause you to divide by 0. So we will say, all right, but no 0. All right, so that breaks my domain up into two pieces. The first one is bracket negative 1/5 comma 0 parenthesis union, that's the first interval, union parenthesis 0 comma infinity. And that's the domain of my new composite function. And that's the last example for this lesson. All right, so I will stop the recording